Hi, Paul. Hi, Mike.
Hello.
Hi, guys.
Hi, everybody.
Yeah, hi. So, a small update. Currently, none of the team leads are available throughout the meeting. So, this meeting will be entirely led by Anthony, who is the flight dynamics and the controls lead, and secondly, Manish, who is the current payload and business lead. So, if you guys are fine, we can start with the meeting.
Uh, have you got your recording started already?
Yes, Anthony, did we start recording?
Yeah, the video is being recorded.
Yes.
Okay.
Hi, Paul. This is Utsav. So, hello, can you hear me?
Yeah, I can hear you.
Okay. Uh, so the airframe, all the body tubes for the airframe have been manufactured already. So this is our nose cone. It's in the post processing phase right now. We are currently doing the sanding for the outer surface to make it properly cylindrical, and all the couplers have been fitted and epoxy to it. So, and our fins are also being attached. We have one last pin to attach, and we will also be doing pin layup over it to reinforce the strength of the pins.
Okay.
And this is our the tip for our nose cones. So we'll be having a nut here that we'll be using to attach the stick. And the bulkheads for the rocket are being manufactured right now. Uh, they should be done within a day or two. They're in the final phase of manufacture. And I'll move on to the recovery part of the rocket. So we will be using a canister-based system. So it's the same system that we used last year. So this is our canister system. So we'll be attaching a canister in this threaded hole, and we'll be having an yeah.
Uh, uh, the the audio is starting to degrade. Um,
Can you hear me?
I can hear you, but it was the quality was getting pretty bad. There was a lot of growling and grunting, and I think the network's having a hard time keeping up.
Uh, just give me
Okay,
a second. I'll try to fix it.
yeah, 1 second. We'll switch off to a different device.
Uh, sometimes, sometimes it helps if people who don't need their video on turn it off. So you've only got one video stream running.
Let's switch it. Uh,
There's no push pin on it. Pin. Oh, it says pin to my main screen. Okay. Yeah. That makes it a little bit bigger. Okay. Now I can see a little bit better. Can you start? Can you start back maybe 2 minutes before I interrupted you?
yeah, sure. So I was explaining about the recovery system of our rocket. So the system that we will be using.
Sorry, one issue. The recording had stopped in middle due to a network error. Uh, it's uh, it's restarted right now. Uh, so yeah, you can start.
Yeah, okay. So I think the recording has been fixed now. So I'll continue. Uh, so yeah, back to the recovery system. So the recovery system we'll be using is a extract canister-based system that we manufacture on our own. Uh, this is where the canister will be going. We will be using a 32 gram CO2 canister for our recovery. And so we have a striking pin inside this. Then the striking pin will be pushed by a black powder explosion initiated by an Emacs connector through this hole. This is a system that we have used last year also, and so we will be following the same system this year. And moving on, I will be passing it on to one of my members who will be explaining about the payload deployment of the rocket.
Hello, Paul. Can you hear me?
Yes, I can.
Hello, I'm Shreya. I'm from the vertical that FM vertical. I'll be explaining the payload deployment system to you right now. So, in the nose cone, we have a fixed bulkhead that will be attached somewhere here, and it will have a in the coupler, and it will have a square shape cutout so that the payload can pass through it. So basically, the bulkhead will be around here, and the payload will pass through this and to the sides of the nose cone. We will be attaching four identical 3D printed molds, epoxying it basically so that there is no empty space in the rocket tube apart from the payload sitting in it. We did that basically to reduce the amount of vibrations that the payload is going through during the ascent. And so basically, after the fixed bulkhead, to the payload, we are attaching a thin mobile bulkhead. So basically, screwing it in with a eye bolt so that we can attach the shock cord to the payload and to the parachute bag and so on. So when the payload deployment separation event occurs, so the uh, tube will first open up, and in the fixed bulkhead there will be a small there will be a hole in the side. We have made the geometry of the bulkhead such that the u-bolt we will be attaching a u-bolt there which will be connected to the rest of the rocket body, and it has been simulated to like withhold the weight of the rocket and recovery impulses. So when the separation event occurs, the parachute opens up, and it basically pulls the payload out of the square cutout, and the payload gets deployed. So that's how the payload deployment recovery event occurs.
So this payload coming out, is that going to be an independent payload or is it
Yes, sir.
still a rocket? Oh, it's independent. Okay.
It's independent. So we'll have two parachutes, one for the payload and one for the main rocket.
Okay. Okay.
Yeah.
And you have a GPS on this payload?
Yes, sir.
Okay. Okay. Okay.
Okay. Can we move on to the next one? Moving on. Yeah.
Uh, Hi, Paul. This is Utsav again. So there seems to have been an issue in the recording part at the initial stages. So I'll be explaining about the airframe once more so that we can get it properly in the recording. Is it fine?
I didn't understand all that. I'm sorry.
Uh,
There seems to have been.
Paul, he was saying in the first few minutes we couldn't record properly because there was some issues. So he was saying, could we record it once more so that we could cover the body tube parts?
Okay.
Yeah. So just take like 2 minutes and finish it.
Yeah. So again, the airframe of the body tube has been manufactured completely. Just the body tubes and the bulkheads are currently in manufacturing right now. They'll be done in a day or two. So yeah, that is the state of the airframe part. And for the recovery system, the canister based recovery system will be our primary system. And we have a black powder based system for redundant part. And we will be using 6 grams of black powder for the redundant black powder system and zero point 0.5 grams in the main canister system for the initiation of the pin. So moving on, I'll be giving it to the controls lead, the flight dynamics lead, who will be explaining about the.
Uh, Hello, Paul. I'm Anthony. I hope you can hear me.
Yes.
Okay. So we have assembled the entire air brake system onto the booster tube. So it's placed right after the engine bulkhead. So we have four symmetrically attached flaps. So currently the flaps are made of fiberglass, but we'll be going with a aluminum-based flaps, which are being manufactured right now. We can show you the deployment of the flaps right now. So right now it's coded to only deploy for a few degrees and restart. Yeah. So yeah, yeah. So the system is powered by a geared planetary geared DC motor. So we are taking the power supply from the avionics bay, which is using a 7S lithium ion battery. Uh, so the avionics bay comes right after the booster tube. So the powering is easy for us. Then we have a dedicated flight computer for the control system, which you can see inside here. So that we don't, our system is entirely independent from the rest of the rocket. It has its own altimeter and IMU to detect the launch phase, and also has the failsafe to ensure the air brake is not deployed in case of an undershoot or in case the rocket tilts more than 20 degrees. And the system also has it's also powered by a key switch. So in case we plan not to go with the air brakes in the final launch, we can simply turn off the whole system and have the rocket launch without the air brake system, with the air brake system acting as a non-active part of the rocket. So any questions from your side?
No, no.
Yeah.
Seems pretty straightforward.
Then I will hand over to Monica, which is from Avionics Vertical.
Hello, Paul. So I'll be
Hello.
showing. So hello. So I'm Monica from avionics team. So this is the avionics bay, and this is our SRAD FC. So we'll be using the TNC microcontroller, and we have the three major sensors: IMU, barometer, and high G accelerometer. So we'll be using the data from all of those sensors, and we're going to be using sensor fusion algorithms like Kalman filters to figure out to handle the main flight events like apogee detection, which is for parachute deployment. And we'll be storing the data in the flash chip that we'll be having through UART. And also all of this will be sent to the ground station through telemetry via LoRa. And that's also going to be going on the same PCB. And the GPS module also we'll be using U-blocks, which is also sent, which the data is also sent through telemetry to the ground station. And apart from that, we have three MOSFETs, which is for the pyrotechnic terminals for the E-match for parachute deployment. Um, and we also have the LED and buzzer to to just show the major flight events that's going to be happening. And that's about the FC. And the FC, the power source for it is going to be from a 71S lithium ion battery pack. Uh, it's a 3C rated 3000 mAh battery pack. And so the voltage will be gotten down from 25.9 using this buck converter here. So that'll be getting it down to 5 volt. and this battery pack is going to be used for both the controls as well as the FC. And we have our altimeter here, Blue Raven altimeter, featherweight Blue Raven altimeter. So we have this is for the COTS altimeter, and we have a separate battery source for this, which will be a 2S1P battery source. Uh, that's also lithium-ion cells, and that will be powering the altimeter, the COTS altimeter, and the COTS GPS, which is also COTS GPS, which is also from featherweight. And about the ground station, so this is a ground station which has a ESP32 room, and then the LoRa module. The LoRa module is going to be the antenna is going to be a 24 dB Yagi antenna, omnidirectional Yagi antenna, and will be receiving data at about 1.2 uh, kilobits per second, and will be operating the LoRa module and the GPS at the 33 centimeter bandwidth. So that's about avionics. Anything that you would like to ask?
So your GPS, you only have one GPS or you have two GPS?
We have two GPS. One, we have U-Blocks module on the flight computer,
Okay.
and we have a COTS module that will be going in the avionics bay.
Okay. The SRAD GPS, what frequency is that?
We'll be using it at the 33 centimeter bandwidth, 915 megahertz.
915 megahertz.
Yeah.
So are you going to need, so is that a total of three because you've got one on the payload as well?
Yes. Yes. We'll
Okay,
control
so
the.
all three of those are 900 megahertz?
Yes. Yes.
Okay.
So do you have any other questions for me?
I'm writing stuff down. Let me think.
Yes, sir. Yes, sir.
Uh, no, I think I'm good with the avionics.
Okay. Thank you.
Thank.
So hello sir, so that's it from our side, like everything we have done. So the entire remaining part of the rocket finishing process should be done in the next 1 week. So we'll be starting with the entire painting and painting scheme of the rocket after the 1 week. So anything you wanna ask or suggest us to do overall?
Well, the minute you get done putting it all together, all the pieces together, then you need to make sure you do all your ejection tests, and I would do those before worrying about paint.
Yeah, yeah. We meant we will be doing the ejection process. Indeed.
You can do painting the last week before you. When do you think you're gonna? Are you shipping it? Are you shipping it freight? Or are you guys gonna try to carry it with you?
We'll be carrying it with us because there's not as much component.
Okay.
Carrying it with us.
So you think you're gonna be done in a week?
Yes, a week, max 2 weeks.
Okay, max 2 weeks. Uh, what motor did you decide upon?
Yeah. So hi, Paul. I will explain about that. So we have decided on using M1939W from Marotech as our motor. Uh,
Uh, say that again. I'm sorry.
M1939W.
Oh, M 1939. Okay.
Uh, we have both a power motor mount bulkhead, and we also have a retainer for it in our rocket, backward retention.
How are you retaining that motor in the rocket?
So we have a motor mount bulkhead at the front, which is sorry. We have a we'll have a bulkhead here that the motor will get screwed into, and we'll have a retention bulkhead here to hold the motor inside. So we have
Okay.
both forward and backward retention for the motor,
What
and we'll
what
be
size
having yeah. That's it.
what size is this airframe? Is that 6 inch?
It's 155 inside.
So yeah, same thing. Um, you're gonna have a motor. Uh, you're gonna have a motor tube in there, aren't you? Motor mount.
Yeah, we have a we'll be having bulkhead that the motor will go into, and we'll be having centering rings here that
I know you have, but the 1939 is a 4-inch motor. It's 98 millimeter,
yeah,
and you've got a 155 millimeter airframe, so
we'll be
you have
having
to
centering rings here to account for that.
do what?
We'll be having centering rings here to account for the change.
Right. Are you using a tube, or are you just using centering rings?
We are just going to be using centering rings. We're not going to be using.
Okay, good. So the centering rings are going to be 150, 2 or 3 OD and 98 millimeter ID.
Yeah,
Okay. Um, let's see. Okay. Uh,
and one more thing that I would like to talk about is for the parachute, we'll be using a reefing system this time, like the same thing that we used last year.
okay.
So yeah, I didn't mention it while mentioning the recovery system. So we have only one main parachute, so we'll be reefing it to. It's a 12 feet full diameter parachute. We'll be reefing it down to 7 feet, and at 1,000 feet, we will be triggering our main deployment, and that will bring it to 12 feet. We will be using piranha cutters and a line to connect the uh, to reduce the diameter. So these are the wires that will be going from the piranha cutter all the way to the avionics bay. We'll be connecting it to the avionics bay, and the signal to activate the piranha cutters will be given from the avionics.
Okay.
Any questions about the motor?
Just show me all the. So where's the separation points on here?
So there are
Or
two
where?
separation points completely. One of the separation points is here, and the other one is here.
Okay. Those are where parachute is going to come out, or what?
Yeah. So the main parachute for the rocket recovery will be coming out from here. Let me give you a big picture. And this is where the payload will come out. The payload will have its own separate parachute, and the rest of the tube will be connected to this wire shock.
Okay. So is that is is that tube at the bottom of your nose cone? Is that your coupler?
Yeah, it's a coupler to this. This is the coupler that will be connected. With.
Okay. 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 And then you're going to figure out shear pins.
Uh, Shear pins we have the ones that we use for our previous year rocket. So we
Okay.
have the shear pins of 2 diameter.
Okay.
We'll be
Okay.
using.
I'm just I'm just trying to see if there's everything covered here.
Yeah.
Okay. So 2 weeks. So in 2 weeks, then I need you guys to give me an update.
Sure.
Uh, and in 2 weeks, if you still have stuff to do, you need to tell me so I can make sure that you're ready to fly the minute you get at Midland, because I don't want it like last year where uh, you were still putting some stuff together. I'm hoping you show up and then you can enjoy the competition and go out and fly a rocket. That's what I want to see.
Sure, boss. Sure. Definitely.
Okay.
Yep.
Okay. But other than that, looks like you've got a good start here.
Thank you.
So let's keep it up. Like I say, in 2 weeks, let's say by
Yeah. So
uh,
thank you.
maybe by the 27th of May. then I'm going to expect you guys to get me pictures and get me a report of where you're at. Okay?
Sure.
So I know, whether you need some help from me or, if there's something that we need to fix or whatever. But
Definitely.
I'd like to see this rocket put together before the end of May.
Yep.
Okay?
Yep.
Okay. Do you have any questions for me, guys? And
Nothing.
okay. Okay. Well, looks like you're doing okay. It's just you look like you're a little late here. So hopefully we can get a rocket together and fly it. Okay.
Yep. Sure.
Okay. You got any questions, Mike?
No, nothing here.
Okay. Okay. Okay, guys. I'll let you guys. I know it's what 8 o'clock in the morning there now.
Yep. It is 8 years.
So I'll let you guys get back to it, and I'll be waiting for your email in 2 weeks. Okay.
Sure, Paul.
Okay. Thank you very much.
Thank you, Paul. Thank you, Mike. Thank you,
Thank you,
guys.
Paul.
Thank you so much.
Thank you so much.
You're welcome. Thanks, everybody.